So, hello everyone, and welcome to this session number 19 of Ask AuxEn Anything. So, this is a weekly online session that we have where the structural civil engineers can interact with us and where they can ask their queries or doubts related to any RCC or steel project that they are doing, or about a particular concept in RCC steel design that they are facing, a doubt in RCC steel design concept that they are facing, or in general construction and site issues. So this is the 19th such session, and welcome all of you to this session number 19. So what I will do is, let me just uh, what do I do? Let me just open the Google form and see what are the questions that we have. After we do the Google form, then we will take the live comments, questions asked in the live comments. So let me just open that and I'll share my screen. Yeah. So what should I do? Yeah, I'll just present the screen over here. So I guess this is visible. So first question, Mr. Akash Babar is asking. He's joining us from Mumbai. If we model only pedestal and plinth beam in STAD and apply all reactions on top of pedestal, then do we again need to apply separate EQ forces by definition instead for pedestal and plinth beam system? Okay, so I'll just copy his question and maybe we'll just take it over here to OneNote and then try to answer it. So what am I doing? Yeah, let me just stop this screen sharing and share. They have changed some. Where is the share screen? Okay. Yeah. So this is his question. If we model only pedestal and plinth beam instead and apply all reactions on top of pedestal, then do we again need to apply separate EQ forces for pedestal and plinth beam system? Pedestal is 3 meter below ground and all plinth beams are of span 8 meters. Pedestal is 3 meter below ground. Okay, so I think he's saying that the pedestal is like this, then you have a footing. This is whatever is the ground level or finished ground level, let's call it. So maybe he's saying this is 3 meters. And yeah, he's saying the pedestal is 3 meters. I have taken the footing bottom to be 3 meters. And then let's say here is the PEV column. There are some anchor bolts, whatever stiffener system. So the PEV reactions have been given at this level. Okay. So here the reactions Fx or Mz or whatever reactions are given have been given at this level. So his question is, do we again need to apply separate EQ forces for pedestal and plinth beam? See, pedestal and plinth beam anyway are going to be at the ground level or below ground. So you need not, I mean, earthquake will have not much impact, not any significant impact, or you can say because they are below ground, they will not have any uh, They will not have any inertial forces, so to say, because they will vibrate with the ground itself. So for EQ forces on pedestal and plinth beam, you may not consider anything, and whatever reactions you are getting from the PEB system, that alone is sufficient for you to design this footing. One thing that you can do is to add up the gravity loads that are getting transferred from the brick wall on this plinth beam. So you have mentioned that there is a 3 meter brick wall also. So the load transferred from the brick wall, that you can add in as gravity load as axial load P in your pedestal and footing design. So that much you can do. Other than that, no need to consider the EQ forces that are EQ forces for plinth beams and pedestal. Okay, why so? Because they are below ground, so you can safely assume that they are going to have no inertia. They will vibrate with the ground. Therefore, we are not considering the EQ forces on plinth beam and pedestal. Okay, all right. The next question is by Mr. Nihal. He is joining us from Kerala. He is a working professional. He is asking how to do stability check of raft foundation with wind and seismic loading, and he has mentioned that the raft is not rectangular. So as I had told you repeated times, that it is better instead of doing manual calculations, because in manual calculations you may not be able to do it properly, especially the differential settlement thing and the moments that may be generated due to differential settlement. This may not be able to be considered properly by the software. So it is always better to do these things in, sorry, these may not be able to be considered properly by manual calculations. Therefore, it is best to do these things in software like Stat Foundation, or SAFE. So overall, what are the stability checks that you should perform? So stability, you should check for overturning. So generally, overturning in rafts or building is not an issue, because the load that you get from gravity load that you get is quite substantial as compared to the moments that are there in the raft. So unless you have this raft which is for a retaining wall, or which is for some sort of retaining system, until unless that is the case, overturning or sliding will not be such a big issue. Okay, so overturning, sliding are not an issue as such. What are the issues then? Uplift, you should check. Uplift means localized portions in the raft where there is loss of contact with soil. This you should check. You should check for differential settlement. So for differential settlement, there is this table in IS 1904 which you should see and ensure that the differential settlement in raft is not beyond that limit. Other than that, I don't think there are any specific or any other stability checks as such required, especially for building, especially for rafts of building, because as I told you that these will not have problems related to uplift or sliding. Okay, all right. Then we have Arasan from Tamil Nadu. He is a working professional. He has questions, and I'll just put it over here. So, Mr. Arasan from Tamil Nadu, and you can put your questions in the YouTube live comments also. Once we take up all these questions in the Google form, then we will take questions from YouTube live comments. So, Mr. Arasan from Tamil Nadu, he is asking, I am designing a commercial building in which 35 feet PT beam rests on RCC beam. PT beam size is 900 by 450. What will be the minimum bearing width of RCC beam required to support the PT beam? So as such, I don't have much, not much. I don't have experience about doing PT systems. Let's try to see what he's asking. So if there are any specific PT norms, I may not be aware. but let's see what you are trying to ask. So I'm drawing a plan, let's say, and this is your PT beam. This is the plan you have drawn. So this is 900 wide and 450 is the depth. Okay, and this is the RCC beam on which the PT beam is resting, he is saying. So now what will be the minimum bearing width required to support PT beam? So right now I am assuming that they are in same level. Are they at same level or you want them to be at different levels? It's not clear from the question whether the PT beam is resting on top of RCC beam or it is resting at the same level. I'm not sure about that. So right now I'm assuming that they are resting, or rather they have been made at the same level. That means this is my RCC beam in sectional view, and this is the PT beam. PT beam is having 450 depth because he had mentioned that, and this is my, so this is PT and this is RCC. So if this is the scenario, same level, okay, same level. So logically, if you ask me, in deciding the widths, of course, you will have to first see whatever reactions are getting transferred from this PT beam. They should be safely be resisted by this main RCC beam. So whatever is the bending moment shear force in the RCC beam, for that the size of this RCC beam width and depth should be sufficient. Second thing that comes to my mind is that whatever is the PT system being employed, your PT system will be having some sort of tightening arrangement over here. So although I don't know it, but if there are any minimum criteria that this much should be the development or embedment length of these strands inside the RCC, that will decide the width of this RCC beam. Okay, that will decide the RCC beam width. Other than that, I don't know if there are any additional concepts. So to my mind, these two concepts uh, you may have to keep in mind while deciding this particular beam width. One is any specific requirements for these PT strands, uh, that they should have some minimum embedment inside the RCC. That is one uh, criteria. The other criteria is that while designing this RCC beam, when it is getting designed for the loads from this PT beam and from for other loads also, the width and depth of RCC beam shall be sufficient. Shear transfer at this interface. So whatever shear forces are getting transferred, you will have to ensure that sufficient depth of this RCC beam and sufficient dimension of this RCC beam is available. So to my mind, this is what I can think about right now. Okay. Okay. Then his next question is, I am design. He is Mr. Uh, Arasan is asking next question. I'll just bring it over here. His next question is, I am designing car parking with rafter and purlin as vertical steel plates to support deck slab. How to design vertical plates for rafter and purlin? I'm not sure what he's asking. I'm designing car parking with rafter and purlin. So you are saying you are using vertical steel plates for rafter. I mean, are you using built up sections? Is that your question? Or you are using only plates in rafter and only plates for purlins? That is, it does not have any flange like section. There is only this type of web plate thing. Is that what you're saying? I'm not quite sure about the question. Only plates. So you are saying there is no separate flange, there is no separate web. There is only one plate, which is sort of a web plate, and that's all what you have. Only web portion. Okay. Okay. Okay, so is that sort of a grid like system that you have created? Have you created a grid like system? So these rafters, so don't call them, let's not call them as rafter purlins. Let's say that, so okay, so if you have tried to create this system, what my suggestion would be, I'm showing you a plan view. Let's say this is your car park and whatever are the columns. In this case, what you can try to do is that you can grid system. Okay, so don't call them as rafter purlins. Rafter purlins usually is the terminology we use when we are, let's say, doing a shed like thing where we are going to cover it with sheeting. Then usually that purlin term is used. Okay, right, so you are using a grid system basically. So in plan view it would be something like this. So I'm showing the plan view. What you see is the web thicknesses in plan. Okay, so you will be placing like this. Are you placing them one on top of other or on the same level? So this is one system. Now are you placing one on top of other? That means one is this green level, and now on top of this are you placing the next level, or the next level will be placed by cutting these pieces in between? There can be two ways, isn't it? One is by cutting these systems in between. So a green is going continue and purple color web plates are getting cut at intersection points. One is this way. So in sectional view, they will look something like this. So if I were to show you a section, my green plate is like this, and on the same level, I have my purple plates also. This is one format of providing the system. Another way could be that my green plate is like this, and on top of it I have provided my purple system, right? So fabrication wise and ease of construction wise, this system is more simpler. This second option is more simpler because you don't have to cut the purple plates at every intersection. But welding, but if you ask me overall integrity wise, I would say this first system is better because the entire system is much more integrated in this first system. So anyway, whatever your system is, what is your question now? So your question is how to design. No, how to design means you, I would suggest you in such cases, you make a model first, apply the loadings, and then whatever moments you are getting, you just try to see what moment shear forces you are getting, and then as a regular step by step process that you do for shear and for flexure, you design. So this time the only section you are having is this. Nine, this is your only cross section. This is your depth. This is your width. Now, only suggestion would be that when you are considering this for flexure, you take it as semi-compact. When you are designing this for flexure, you treat it as and of course, right now I'm speaking in terms of Indian code. So you consider it as semi-compact. So that means you take the moment as Fy into Ze. There is, when taking the lateral torsional buckling length for this green plate, you can take this distance as the length for lateral torsional buckling. Okay, so that's how you can check the LTB effect also. For this purple thing, the LTB length can be taken as this. Okay, so this is how you check for flexure. For shear, you see whether it is in shear buckling and whether it is in shear buckling or shear yielding. As per that, you find out the shear capacities. And of course, for compression, if there's any compression, you treat it as class C. So in this manner, you can approach this. So make a model first, apply the loadings, check the movements, check the movements and shears, and then For flexure, as I just told you, you assume it as a semi-compact thing, semi-compact cross section. For compression, you take it as class C, and the lengths I just mentioned. Okay, so something like this you can do it. Of course, also see deflection, because this grid-like system. Please check the deflection of this system also. Good. So, yeah, this was the question. Mr. Nihal Babu is asking, what will be the difference in model in both cases? Okay, so he's saying, how can we make these two models separately? Because in one, at in first model, let's say they will have common center lines. In second model, the center lines are at different level. So how can you do it in model physically? So in model, it may be difficult to do it physically unless you are making an actual plate-like model. If you are doing a frame modeling, it will be difficult to create this model too, because the default setting will be that it creates a model like model 1. So model 2 will be slightly difficult to create, but then you can use that offset commands available. So using the offset command, maybe you can create this model too. Loading wise, I don't think there is going to be, I mean, analysis wise or the output wise, there might not be any difference. But then you will have to see while doing the detailing designing that for this system, you will have to ensure that the junction between green and purple, it has to be properly detailed. Okay. So that you will have to ensure and see that is being uh, catered for in the detailing. Okay. Mr. Arbaz Qazi is asking, can you explain when to design beams for torsion? In our office, we only design beams for torsion when it is a circular beam, or when there is a cantilever slab and slab beam has different thickness, and the slab behind the beam has different thickness. Okay. And the slab behind the beam has different thickness. So we have discussed this torsion issue several times before also. My only thing is that design, you will have to design beams in torsion essentially when it is a case of equilibrium torsion. Then you cannot not design the beam for torsion. If it is a case of equilibrium torsion, you have to design the beam for torsion. If you have compatibility torsion, if you have compatibility torsion, then in that case, as a designer, you can choose and accordingly decide whether to design your beam for torsion or not. But then whatever decision you are taking for compatibility torsion, ensure that appropriate detailing is provided. Okay, it should not be such that you have not provided appropriate detailing and then you have also ignored the torsion. Don't do it like this. Ensure appropriate detailing and choose to do choose if you want to do design your beam for compatibility torsion or not. If it's a case of equilibrium torsion, it's essential that you have to design your beams in torsion, otherwise system will not be stable enough. Okay. All right. Any other question we have? So I think in the Google form, these were the questions. Any other question from the live comments? Mr. Nihal Babu is saying, in RCC retaining wall, which point to be taken for lever arm calculation, heel or toe? What is reverse L shape? I don't know. Okay, before that, Mr. Tamila Rasan is asking. Okay, he's continuing with his question. For plate model of grid, I'll just take this first. So he's saying, for plate model of grid system, which stress component under plate stress contour to be seen? For bending stress, it should be less than 0.66 Fy, and shear stress less than 0.45 Fy in stat. Okay, so you have made a plate model out of it. So see, for bending, you may not be able to get directly the plate stresses because of the bending behavior of this plate and the way in which you will draw the plate. You will have to check for the F these stresses, F11 stresses. So these will actually give you the bending stresses. So from these F11 stresses, you will have to back calculate the moment capacity. You get my point? So basically in stat, the mx, my stresses will not be helpful. You will have to check the F11 stresses, which are nothing but the compression, tension, bending, compression, bending, tension stresses. So you will have to check that. So my opinion would be in such a case, it is better to draw it like a line element rather than going for a plate like system. I would say that even a line element type of model will work because you will not be able to extract the required outputs properly if you have done a plate like modeling, because in this case the F11 stresses will be important. Okay, so plate bending, see in this case the green plate bending, what it will have is your green plate bends like this. So you need the bending stresses which will be shown by F11 or whatever stat calls it as Fx. What I'm forgetting what stat is going to call it, but the bending stresses will have to be checked in this manner. Okay. Okay. Mr. Nihalu is asking in RCC retaining wall which point to be taken for lever arm calculation. So it will depend on the type of wall and the way in which it is going to bend. So if bend means deform, overturn. So if this is your wall and let's say here there is fill and here the fill is over here. So this system overall will have a tendency to overturn about which point? You tell me about this point A or point B. This system will have a tendency to pivot about which point? So this system will have a tendency to pivot about this point A. Yes or no? So in such cases, you will check all your overturning effects about this point. You get it? So it will depend on what type of system you are having. As per that, about whichever point the system will have a tendency to turn, that point should be taken for lever arm calculations, and that should be taken for calculating the overturning moments and resisting moments. Okay. Mr. Arbaz Kazi is saying how to decide the depth of raft foundation in a high-rise building. Our managers directly give us sizes of depths of. You mean they directly give you the depth at 2 meter, 2.5 meter, 3 meter. Okay, you are saying depth, thickness of raft. You're saying thickness of raft? Yeah. So see, thickness of raft in these types of high-rise buildings, the thickness of raft will be decided by the governed by, I would say, the one-way shear and two-way shear requirements. Okay. So one-way shear plus two-way shear requirements are going to govern it. So your managers are able to give you directly because of the experience that they may have had of doing similar projects. That is the reason why they are able to give you directly the thicknesses, but they will usually raft thicknesses will usually be governed by the one-way shear or two-way shear. And because in most cases one-way shear, two-way shear requirements are uh, exceeded by the thickness that you provide, so in most cases you will have to also give the reinforcement for shear. So mostly shear reinforcements will also be required. So when shear reinforcements are also required, what you try to do is that you choose a thickness of raft in such a way that your shear reinforcements are manageable. That means you don't get a very heavy requirement of shear reinforcements. So manageable shear reinforcement is what you desire for, and accordingly depths are usually decided. So depth criteria usually will always depend on the one way or two way shear requirement. And as I told you, shear reinforcement that you can easily manage. So see, if your thickness is very low, what will happen, that your punching stresses, two way shear or one way shear will be very high, so you will need a very large amount of shear reinforcement. If you increase your raft thickness, your shear reinforcement will go down, shear reinforcement requirement will go down. If you provide a very very thick raft, your shear reinforcement is totally eliminated, but then that may not be the best optimized solution. So you have to strike a balance between the raft thickness that you're providing and the shear reinforcement requirement. So you can so what your managers are doing is that, because of their experience of doing such projects, they are able to assess that for this type of building height, and they know that such a building height, approximately this much is the total column load on your total raft. These are the column to column spacing. So in that, from that they are able to assess the raft thickness. But for you, you can do it by doing some preliminary calculations required related to one way shear and two way shear requirements in raft. Okay. Okay. Then Mr. Suraj is asking, he has put a question, I'll just put it over here. He's saying, can you please check your email? So I'll just copy his question and put it over here. Let me increase the font size. So he's saying, in our RCC tall structure course, defining and assigning three-dimensional spec Z. So he's saying response spectrum in vertical direction is not included. I have seen some of the consultants have included spec Z also during the analysis of tall building. Can you please tell us how to define and assign spec Z in response spectrum case? What might be the changes in load combinations with inclusion of spec Z, and what are the stability analysis checks that has to be performed for those cases which are that? Can you please enlighten this in brief? Is there any different provision for defining spec Z, or is it the same? Okay, so see, generally what we do is, instead of defining the response spectrum in Z, we treat it as a part of or as some percentage of the horizontal earthquake forces. As a percentage of that, we define our vertical earthquake. Okay, in vertical earthquake definition, generally we may not have the graph like this. Okay. Sorry, response spectrum graph is like this, rising arm also. So this may not be the type of graph that we may have, is not available with us when we are defining the vertical earthquakes. So generally, the graph that we consider, suppose you wanted to define, is a constant SI by G graph with respect to the time period. Usually, it will be taken as two-thirds of AH, if I remember it correctly. So the way to define vertical earthquakes will be to define them as some percentage or as some fraction of the horizontal earthquake. I will also have to check the procedure. I have some models where they have included the vertical earthquake over there, so I'll have to check that the actual process in which they have done. But similar to this, what I just said, they will be doing that. Instead of having a SI by G curve like this, varying with time period, they will define a constant SI by G with respect to time period, and the factor will be taken as two-thirds of AH. That is the multiplication factor. So in this manner, you will define for load combinations. Your code has clearly given you how to include vertical earthquake. So you can go to IS 1893 also, and your IS 16700 also directs you to 1893 for vertical earthquake load combinations. When to take vertical earthquakes, that has also been quite clearly given, under which conditions you have to consider the vertical earthquakes. Okay. For defining it in ETABS, you can look for some YouTube videos where they have explained quite well how to define vertical earthquakes in your actual ETABS model. Okay. All right. Anything else? Do we have any other question? Okay. So I think then that's it for this session. There are no more questions. We have taken all the questions from the Google form, and there was one question on this email. We have taken that also. So I guess that's it for this week. We will see you next week now, and we will be doing it on Sunday morning because of the feedback received. That Sunday morning is more convenient. So we will have another session now on next Sunday morning at 11 a.m. IST. So that's all. Thank you and see you next weekend. Have a good week until then. Bye bye.